Match the level of confidence C equals 0.88 with its representation on the number line, given that x bar equals 55.7, sigma is equal to 7.6, and n equals 95. Well, remember that when we talk about confidence intervals, we're going to use the following formula or statement. We'll have x bar minus our error, and that is going to be less than or equal to the population mean less than or equal to x bar plus our error. Now remember that error is going to be given by the following formula of z sub c, which is our critical z value, times the standard deviation divided by the square root of n. Now we know what x bar is, we know what sigma is, and we know what n is. Now we need to figure out what z sub c is. Now, to find z sub c for this thing, we're going to use the following. We're going to find 1/2 times 1 minus the critical or the confidence level that's given. In this case, it's 0.88. And the reason we do this is because the level of confidence C will be the area under the standard normal curve that is going to occur between our critical values of a negative z sub c and a positive z sub c. So this area, this right here, represents the area outside, and we're trying to find those z values that are going to define the area inside. So since c is equal to 0.88, as we see up in the original problem, we're going to have 1/2 times 1 minus 0.88. And that will be equal to 1/2 times 0.12, which will be equal to 0.06. And this is what we're going to look for in our table. Unfortunately, when we look at this, we're going to find that 0.06 does not occur in the table. When I'm looking, I find a number of places where we're close to 0.06, and in fact, these two values right here are going to be less than 0.06 and greater than 0.06. And 0.06 is going to fall in between those two values. And so we're looking to split this. And why are we going to split this? Because if you notice, 0.0594 and 0.0606 are the exact same distance away from 0.06. And as you can see, since 0.06 is the same distance away from those two values, I'm going to go ahead and split the difference, and we will use a value that is between this. So we note that the z-score is going to be between negative 1.56 and negative 1.55. However, we want to make sure that we use a positive value. So z sub c for this particular problem is going to be equal to 1.55. And that's going to be what we're going to use when we determine our confidence interval. So using our newfound z-score, we'll go ahead and calculate the error. So E will be equal to z sub c, which we have just discovered to be 1.555. And we're going to multiply that by the standard deviation of 7.6, which we know is right here. And we're going to divide that by the square root of the sample size. and the sample size is 95. And when we calculate that out, we will get 1.212. But we're really only concerned with this initial part of it, the 1.2, since if you look at our answers up here, they are carried out to a single decimal place. So how do I figure out what the confidence interval is? Well, as I said, we're going to use this statement right here. So if x bar is equal to 55.7, we will have 55.7 minus 1.2 less than or equal to the population mean less than or equal to 55.7 plus 1.2. And then when we calculate this, we'll see that this value right here will be 54.5, and that will be less than or equal to the population mean, which will be less than or equal to 56.9. And now we simply say which one of these, or which does this interval match up with over here, and that would be choice B on the number line.